All right, good evening, everyone. So in this class, we want to have a very detailed discourse around polynomials. Uh, this is a very interesting topic, which I would love every student to have clarity on. All right, to start with, if you're going to be very great at solving polynomials, you need to first understand the definition of polynomials, because you need not confuse polynomial with just any expression. You need to be very clear on what exactly is a polynomial. So I'll be defining a polynomial for you, and I would love you to pay real attention to the definition, because very soon we'll be identifying different polynomials. So, and if I give you a particular expression, I would love you to tell me if it's a polynomial or no. All right, so let's define a polynomial. A polynomial is the sum of separate terms. The whole is the sum of separate terms. Every detail of these definitions is quite very important and significant. It's the sum of separate terms of positive power of a variable with constant term. With constant term. Every part of this definition, you need to pay real attention to it, which may be zero. That means the constant term may be zero. I believe at the end of these classes on polynomial, you should become a professional when it comes to solving polynomials, or a polynomial function. All right. Now, I would not like to bore you with the general term of a polynomial, because that's just good. That's good, but I would not want to bore you with that. I want to go straight into identifying polynomials. All right. Now, let me break down these definitions for everyone. Pay attention to the first thing that was said. Number one, polynomial is the sum. Is the sum of separate terms. Separate terms. That means when we're dealing with polynomials, we have terms. If you're familiar with binomial expansion, you would see that when you're dealing with binomial expansion, we talk about the first term, the second term, and so on and so forth. Now, this next thing I want to point out is very, very significant. Positive power. You see this word positive, you need to pay real attention to it. The word positive is very, very important. Now, of a variable, I'm sure you understand what variables are. They're like case holders. In mathematics, we signify variables using alphabets in some cases, or using some symbols. So when we talk of variables, we talk of x value, y value, p value, a value, and so on. So I'm sure you understand that. So with constant term, which may be zero, or a polynomial function. Now, when you talk of polynomials, let me just give an example of polynomial, and then I will give you an example of a function that is not a polynomial. So you have to be very careful in identifying polynomials. Let's say, for instance, we have a polynomial that has 3x cubed plus 4x minus, or 4x squared minus 5x plus 6. All right, let's see how this conforms to this definition and why this is a polynomial. Of course, I want you to know that not everything that has this form, an expression, not every expression that has a variable is a polynomial. Let me state that again. Not every expression that has a variable is a polynomial. You have to define a polynomial with every detail that has been highlighted in its definition. So when we say a polynomial, number one, we said it's the sum of separate powers. Of course, you can see right here that we're dealing with sums. Now, I'm sure somebody right there in the audience will say, how do you call a negative sign a sum? Of course, let me prove that to you why this is still a sum. It's still a sum because we can write this as 3x cubed plus 4x squared plus minus 5x plus 6. So it's still essentially a sum. Of course, I'm sure you understand that. Now, we said separate powers. Of course, separate terms. You can say this is a term, this is a term, this is a term, this is a term. So we can have one term, we can have two terms, we can have three terms. It's all fine. It's still a polynomial. So that's that about that. Now, this is the next one I want to talk about, which is a very key ingredient for defining your polynomial. And that's the word positive power. You see, I told you earlier now that you don't just say every expression that has a variable, maybe x or y, it's a polynomial. You have to go on to check at the power. The power of a polynomial must always be positive. So if you have a case where you're dealing with situations like, let's say for instance, you have 3x cubed plus 4x raised to the power minus 2 minus 5x plus 6. Now, even though this looks very much similar to this, but you see, we can see minus 2 right here. This minus 2 makes this particular expression not a polynomial, because a polynomial has to do with positive power of a variable. So without that, you cannot define it as a polynomial. So this is not going to be a polynomial, while this is a polynomial, because it doesn't conform to the definition of having a positive power for the variable. Now, let's go to the next word we have here. It said with constant term. Now, I want you to understand that constant term, when you're dealing with expressions, they are those terms that are void of a variable. That means they do not have a particular variable attached to them. All these terms, term 1, term 2, term 3, they all have a variable attached to them. But this particular term, which is a constant term, doesn't have any variable attached to it. So that's what we mean by constant term. Now, it said something. It said this constant term may be 0 or a polynomial function. I need to explain that part of this definition to you so that you are very clear about it. So you need to understand that it's not compulsory that you must have a constant term written like this. It's possible that this polynomial is written like this. If you had it like this, let's say minus plus 6 is erased out. This still is a polynomial. Now the question will be thrown at me that you told me that a polynomial has separate terms of positive power of a variable with constant term. So the question remains, where is the constant term in this particular function? Of course, the constant term is right there. Only that the constant term in this case is 0. That's why we said the constant term may be 0. In this case, the constant term is 0. Then we went on to say, or a polynomial function. You said, what exactly is a polynomial function? If I had plus 6, I want you to understand that that was a polynomial function. Let me explain to you why we call it a polynomial function. 6 is the same thing as 6x raised to the power 0. So that's why we call it a polynomial function. It's still a polynomial function, only that in this case, the power of x is equals to 0. And of course, I'm sure you understand that when something is raised to the power of 0, we have it as 1. So that's why we just write it as 6. So I want you to understand that when dealing with polynomials, it's not every time you're going to be having a constant term written probably as an whole number or whatever you have there. It's possible it could be 0. So this is the definition of polynomials. Let me go over it one more time. It's the sum of separate terms of positive power. Very, very key. It has to be positive power. Once you are able to derive a negative power from any of the terms, you will never, ever call that a polynomial. That has rendered the definition invalid at that point. So it's the sum of separate terms of positive power of a variable. With now, I want you to understand that polynomials don't always have to have x variables. That's why we said of a variable. It doesn't have to be x variable. It could be y, it could be p, it could be z, it could be a, it could be anything. So once you have a variable, variables are case holders. Anything could be, the meaning of the word variable mean it could vary. So x here could be -1 at a point, x could be 2, x could be 3, x could be 10. That's the meaning of the word variable. It varies. It's not constant. 6 is 6 anywhere. Anywhere you carry this value to, it's 6 everywhere. But you see 5x here, this minus 5x here, could be anything depending on whatever you decide to fix in x as. And that's why we call it a variable, because it's going to vary based on whatever you feed in the x value has. Or 6 is going to be 6 anywhere you take it to. All right. So now with constant term, which may be 0, I have to explain that, or a polynomial function. All right, let's go quickly to identifying polynomials, because this is very key. And from here, we'll move on to addition and subtraction of polynomials, then move on to multiplication of polynomials, then we'll move on to division of polynomials, then we'll go on to talk about the factor theorem, the remainder theorem. We may not be able to finish everything in this particular class, but I hope we can exhaust ourselves on polynomials either today or tomorrow. All right. Now, I want to be writing different expressions, and I would love you, the audience, to tell me if this is a polynomial or no. So this is a moment where I would love interaction in this particular class. I would love you to tell me if whatever I wrote is a polynomial. All right. The very first function is 2x cubed minus x. We have 2x cubed minus x. Is this a polynomial? Yes or no? Somebody say it's not a polynomial. Why is it not a polynomial? Of course, the very first one I wrote is actually a polynomial, because it conforms to the definition we just said. This is the sum of separate terms of positive power of a variable. The sum, I told you this could also be written as 2x cubed plus minus x. So it's the sum of separate terms. Of course, that is highlighted. You can see these are separate terms. And you can also see that it has positive power for the variable. None of the variable is having a negative power. The variable here has the power of 3. The variable here, the same variable, has the power of 1. So this conforms to our definition. So we're going to define this as a polynomial. All right. So that's good. Now, the next one we have 0.2x minus 1 over 7. Is it a polynomial or no? What do we say? Is 0.2x minus 1 over 7 a polynomial or no? All right, let me get answers. I will settle for a great answer there. Okay. Somebody said it's a polynomial. Any more options? Okay. Okay. Now, let's examine this based on the definition we just gave. Separate powers, separate terms. Of course, these are separate terms. I don't need to highlight that this could also be plus minus 1 over 7. So that's, of course, this is a constant term here, which is not 0. This is actually a polynomial function. Just so you understand, let me try and highlight this a bit more. This is, I can write it like this. So you can see that this, in this case now, doesn't have, in this particular case now, the constant term was 0. You can see that we don't have any value there. The constant term here was 0. Here, the constant term is a polynomial function, which is seen like this. X raised by 0 is 1, so that's why we did not have to write that. Now, can we see, is there any negative power here? There's no negative power. So, of course, this conforms to our definition of what a polynomial is. So, we're going to call this a polynomial. All right, let me give you the next one. We have x plus 1 over x. All right, is this a polynomial? Is this a polynomial? I'll settle for an intelligent answer there. Is this a polynomial? Somebody said it's not a polynomial. Another person said it's not a polynomial. Okay, I'm not seeing anybody that will say it's a polynomial. All right, let's examine this based on our definitions once again. Let's see this. If we're going to write this in a better way, we could write this as x raised to power 1, obviously, plus, of course, 1 over x is the same thing as x raised to power minus 1. All right, now this already negates our definition, so we cannot put this up as a polynomial, because polynomial defines clearly that we have to have the highest power. Sorry, we have to have our powers to be positive. So this is not a polynomial. All right, let's go to the next one. We have x minus 1, x minus 5. Is this a polynomial? X minus 1, x minus 5. Is this a polynomial? Is this a polynomial? Let me write the next one. Okay, let me hold on. Is this a polynomial? Do we have this as a polynomial? X minus 1, x minus 5. Is this a polynomial? Some people said yes. Okay, people are saying yes. Somebody is saying yes. Is this a polynomial? Somebody is saying yes. All right. Now let's examine this. How do we know it's a polynomial or not? Of course, for you to do this, you have to first try to investigate by opening this whole bracket. We have x squared minus 5x minus x plus 5. This gives me x squared minus 6x plus 5. So let's examine, does this conform to our definitions of what a polynomial is? It's the sum of separate terms of positive power. Separate terms, okay, good, I see that happening. Positive power, is there any negative power? 2, 1, okay, there's no negative power here. Okay, so it doesn't negate our definition, so we're going to call this a polynomial. Good. Now let's see this next one, 1 over x minus 3. What do you say? Is this a polynomial or no? Is this a polynomial or no? What do you say? Is this a polynomial? Is the next one a polynomial? What do you say? Somebody said it's not. Anybody with a different option? Somebody is saying it's not a polynomial. Okay, other people are saying it's not a polynomial. Why is it not a polynomial? Of course, if you're going to write this in a much better way, you can also write this as x minus 3 raised to power minus 1. Now, this already tells you already that the power of your x will not conform to it being positive. So we cannot put this as a polynomial. So we have to define this as not a polynomial. All right. So I'm sure with what I'm seeing right here, I'm sure almost everyone in this class has gotten the right understanding of what a polynomial is and what a polynomial is not. Let me see this particular question. Let me see what you do with it. 2 raised to power x minus 1. Is this a polynomial? Is this a polynomial? Do we call this a polynomial? I'm not sure if you can see that clearly. Please confirm if you can see that clearly. Let me try. 2 raised to power x minus 1. Is this a polynomial? Is this a polynomial? People are saying no, it's not a polynomial. It's not a polynomial. Why is it not a polynomial? People are saying it's not a polynomial. Do we all agree with that, or do we have an argument against that? All right. Yeah, let's try and examine this. What was our definition? We said it's the sum of separate terms. Sum of separate terms of positive power of a variable. Positive power of a variable. Pay attention to that definition. Positive power. Positive power of a variable, and so on and so forth. When you look at this, where is the positive power of the variable? You are using, in this case, your variable is actually the power here. This doesn't relate with what we have known for polynomials. So it's not raised, we're not having, like in this case where it was x, the variable raised to the power of something. Now we're having 2 raised to the power of x. So this clearly is not a polynomial. This is not a polynomial. So you have to investigate based on the definitions that you were given. All right, let's say we have x squared plus 3x over x. X squared plus 3x over x. Is this a polynomial? Is this a polynomial? Is this particular function or expression a polynomial? Let me get answers, intelligent answers quickly. This is how we understand a topic perfectly. We have to dig into every detail. And once we're done with that, we're going to be quite very great at solving it. Is this a polynomial? What do we say? We have x squared plus 3x over x. Okay, nobody has the right answer. All right. Now let's investigate this question clearly. When we have a question like this, what we have to do is to go on to try and dissolve it. So let's try and examine this. This is x squared over x plus 3x over x. What does this give me finally? I'm going to get x, that's x goes in x squared, we'll be left with x. X here we cancel, we'll be left with 3. So now this is what our result is. Is this a polynomial? Of course, yes, because it doesn't negate our definitions. We said it's the sum of separate terms of the positive power of a variable. Now, we can see the variable here is having a positive power, and there's nothing here that gives us anything different from what a polynomial is supposed to be. So this clearly is a polynomial. This can you indicate if you can still hear me right there? All right, let's get another question quickly. Yeah, the last one on this particular aspect. We have x squared plus 3x plus 1 all over x. Is this a polynomial? Is this a polynomial? Do we say this is a polynomial? What do we say? X squared plus 3x plus 1. All right. If you're going to solve a question like this, you have to examine each of the terms based on the denominator. In this case, we'll be having this as x squared over x plus 3x over x plus 1 over x. Of course, this will be giving us, x squared over x will give me a value of x, and then 3x over x will give me a value of 3. Then we'll be left with 1 over x. Now, if I'm going to dissolve this further, I'll be having x plus 3 plus x raised to the power minus 1. So is this going to be a polynomial? Of course not, because it negates the attributes of a polynomial, which has to have only positive power, which it doesn't have. So this clearly is not a polynomial. All right. So that's that about identifying polynomials. So we can go on now to try and make some operations around polynomials. And the very first mathematical operation we'll be dealing with when talking about polynomial will be the addition of polynomials. So now that we know polynomials, can we go on to solve questions around basic operations of polynomials? All right. Now, the very first operation, as I said already, is the addition of polynomials. For you to add two polynomials together, you need to, first of all, examine the powers. The powers are the determinant of how you're going to make your operation. So let's look at these two polynomials. We have the very first polynomial given as, we have our polynomial 1 given as 2x cubed minus 3x squared plus 5x minus 7. And we have the other polynomial given as given as x cubed plus x squared minus x plus 1. All right, so we have basically these two polynomials, and we want to perform the very first operation, and that's the addition of polynomials. So these are the questions we want to answer for this particular question. Question number A, we want to find P1 plus P2. Question number B, we want to find P2 minus P1. That will be the subtraction of polynomials. And question number C, we want to find 2P1 minus 3P2. All right. So here we have this problem in front of us to solve, and this is how you go about solving polynomials. Now you have two polynomials. You want to add them together, P1 and P2. So what I will ask you to do is to go on to fix the first polynomial and then you are adding this with the second polynomial, which is x cubed plus x squared minus x plus 1. All right. So what you want to do is to go on to open all these brackets. The reason why you have to do this and follow this step is because in some cases, the sign here, like in the case where you have a negative sign, would have affected what you have in the bracket. So you want to always use your bracket initially before going on with whatever operation you are trying to do. So now we're trying to add this. So I can open this all brackets. So I have 3x cubed minus 3x squared plus 5x minus 7 plus x cubed plus x squared minus x plus 1. All right. Now, what we want to do next is to bring the like terms together and look for a way to add them together. So we have 2x cubed here, we have x cubed here. So we want to go on to give this operation 2x cubed plus 3x cubed. That will give me my answer as 3x cubed. And then we go on to examine for the squares, the one that has raised to power 2. We can see minus x squared here, and we can see x squared here. Minus x squared plus x squared will give me a value of minus 2x squared. Then we can see our value of 5x and our value of minus x. So 5x minus x will give me a value of plus 4x. And then I can see my last value, which is a constant term. I can see minus 7. I can see plus 1. So what I want to do there is to have the addition done. Minus 7 plus 1 will give me minus 6. And this is my answer for P1 plus P2. So this is how you perform the operation of addition on polynomials. This is the basic way of going about that. So let's try and solve question number 2, which was the subtraction of polynomials. So we're trying to solve for P2 minus P1. So once again, you want to go on to bring all this into brackets. So I want to have my P2 first. This time it is P2. We have x cubed plus x squared minus x plus 1. Now minus P1, we have minus P1. So we have P1 in a bracket, 2x cubed minus 3x squared plus 5x minus 7. All right. So you can see what we have here. This is the reason why I told you to always use your bracket, because you can see right here now, you will have to use this minus on all of the terms in the bracket over there. So you want to open your bracket at this point, you'll be having x cubed plus x squared minus x plus 1. And you open this bracket having the value of 2x cubed minus 3x squared minus, plus, because minus will make it plus. Then we have the minus 5x and plus 7. All right. Now, the next thing you want to do at this point is to go on to identify the like terms. And these are the terms with the same power. So we can see x cubed right here. We can see minus 2x cubed right here. So x cubed and minus 2x cubed, you bring them close to each other, you'll be having x cubed minus 2x cubed will give you your value of minus x cubed. Of course, you'll be having minus x cubed. We're having a value of minus x cubed. And then you go on to have the x squares. That was x squared, then plus 3x squared. When you're having those, when you bring those together, you'll be having plus 4x squared. Then you have minus x minus 5x. Minus x minus 5x, that will be minus 6x. Then you have plus 1 plus 7. That will give you a value of plus 8. All right. So this is how we perform the operation of addition and subtraction when dealing with polynomials. So this is my value when I was trying to solve for P2 minus P1. Now, the last but not the least question we have on our list here is 2P1 minus 3P2. Now, this looks so much like what we call scalar multiplication in matrix. Of course, in this case, this is also multiplying a polynomial with a particular scalar. So we can see we have a scalar of 2 for the matrix, for the polynomial P1, and we have a scalar of 3 with the polynomial P2. All right. So we have to go on to first examine the scalar multiplication before going on to make the subtraction, which was the other operation you were told to do. So in this case now, let's try and find the first thing. That's 2P1. What's going to be my 2P1? So what you want to do when you have a question like this is you want to first examine 2P1, the very first element in the room, and that's 2P1. So you want to go on to have 2 into brackets, whatever P1 was, that's 2x cubed minus 3x squared plus 5x minus 7. So you want to examine this, and this will give you a value of 4x cubed minus 6x squared plus 10x minus 14. So this is my value for 2P1. This is what I got for 2P1. So I want to go on to find for 3P2. 3P2. So I want to go on to find 3P2. This will be 3P2. That's 3 times the polynomial 2, the second polynomial. So I have 3 into bracket. I fixed in my polynomial 2 inside. X cubed plus x squared minus x plus 1. So what we have here is 3x cubed plus 3x squared minus 3x plus 3. All right. So we have been able to solve for 2P1 and for 3P2. So now we can go on to now have the final operation, which was the subtraction of polynomials. So this is the next thing we now want to do. We want to go on to subtract these two polynomials. All right. So now to find 2P1 minus 3P2, of course, you want to bring in your value for 2P1. That will be 4x cubed minus 6x squared plus 10x minus 14 minus, I told you to always use your brackets when dealing with polynomials, because you don't want to you don't want to make the mistake of not using your minus for your bracket. So what we have for 3p2 here, we have 3x cubed plus 3x squared minus 3x plus 3. All right. So I want to go on now to open up all the brackets. So I'll be having my value of 4x cubed minus 6x squared plus 10x minus 14. Then I have minus 3x cubed. Then minus times plus, we have minus 3x squared. Then minus times minus, I have plus 3x. Then minus times plus, I have minus 3. All right. So you can see the importance of having your bracket. Very, very important when dealing with polynomials. All right. So what do you have as your final result here? So you go on to collect the like terms as usual. We can see 4x cubed right here. We can see minus 3x cubed right here. So I want to go on to have 4x cubed minus 3x cubed. That will give me my value of x cubed. All right. X cubed. Then I have minus 6x squared minus 3x squared. That will give me my minus 9x squared. All right. Then I have plus 10x plus 3x. That will give me plus 13x. Then I have minus 14 minus 3. That gives me my value of minus 17. All right. So this is how we are able to get our final answer for this particular question, number C, as this. So the final answer for 2p1 minus 3p2 is given as x cubed minus 9x squared plus 13x minus 17. So this is how you perform the operation of addition and subtraction under polynomials. So let's run quickly to the other operation we have to talk about, and that is multiplication of polynomials. All right. Let's quickly talk about multiplication of polynomials. We could actually use this particular question, and all right, let me decide to let's use a separate question for this. So how do we multiply polynomials? Then after this, we can talk about division, which I know is where a lot of students have issues at, although it's quite very simple. How do we multiply polynomials? Of course, you have been able to define a polynomial. So I'm sure at this point, everyone in the audience can easily make a definite distinction between what is a polynomial and what is not a polynomial. Well, let's talk about multiplication of two polynomials. So let's take a very simple polynomial. Let's say we have 3x minus 1. We have the very first polynomial, 3x minus 1. And then we have the other polynomial as x plus 2. So we have x plus 2. Now, this is quite basic, and I'm sure you all understand how to go about this because it's very simple to do. This, of course, it's more like the approach you had when you were dealing with algebra. But in this case, now we're dealing with polynomials. So how do you multiply this? You multiply this by taking the first term here, then multiply with all the terms here. Then you take the second term here, multiply with all the terms here. So what you have here, you have 3x squared plus 6x minus x minus 2. Then you go on to dissolve whatever is dissolvable. So we have 6x minus x will give me 5x minus 2. So that's how we solve polynomials. Of course, this was quite simple. I don't want to, let me give you this to try, and just for the sake of those that are still probably just new to this. Imagine you have x squared plus 2 rather, and you have x minus 1. So how do you solve this polynomial? You are asked to multiply these two polynomials together. So what you do is still the same thing. You pick the first value here, that's x squared. You use it on all the values here, x minus 1. Then you go home with the other value, that's plus 2. And you use it for everything you have there, x minus 1. So what you have here is to go on to open up this bracket, that's x cubed minus x squared plus 2x minus 2. All right. There's nothing else to solve here, so this is our final answer. All right, so I'm sure you can easily relate to all of these. Let's solve one last question, and then we will be good to move on to a different aspect of this. So let's see x squared minus 2x minus 3. X squared minus 2x minus 3. Let's assume we're told to multiply this with x squared plus x minus 1. All right. So this looks a little bit large and voluminous, but of course, it's still very much solvable. So let's try and solve this so you get a perfect understanding of how to multiply two polynomials. So as I said already, what you have to do here is to bring in each of the terms here and use with all of the terms here. So if I'm going to do this following that same pattern, I have to have x squared. Then I have all the terms here. That will be x squared plus x minus 1. Then I have minus 2x, which was the other term here. This was the other term here. So I have minus 2x. Okay, let me use a different line. Let me use here. Minus 2x, of course, the same thing, x squared plus x minus 1. Then minus 3. Then I have the same thing, x squared plus x minus 1. This is a very sure way of never missing your answer. That's why I will always advise you take things step by step. All right. So what do you do next? You want to open up all the brackets. X squared times x squared will give you a value of x raised to the power 4. X squared times x will give you a value of x cubed. X squared times minus 1 will give you a value of minus x squared. That's that about the very first bracket. Then the next one we have minus 2x times x squared. You'll be having minus 2x cubed. Then minus 2x times x, you'll be having minus 2x squared. Then minus 2x times minus 1. Of course, minus times minus gives you plus 2x. Then what do we do next? We do for the very last one there. Minus 3 times x squared, that will be minus 3x squared. Minus 3 times x, we have minus 3x. And minus 3 times minus 1, we have plus 3. Minus times minus gives us a value of plus. Now you can see what we have right now. Now we have to go on to now try and solve whatever is solvable. I can see that there is no other term here that has the value of x4, x raised to the power 4. So I can keep this very safe here. X raised to the power 4 remains. Then I can check for x raised to the power 3. I can see x raised to the power 3 here. I can see x raised to the power 3 here. So what I'll be having is, in this case, when I have x raised to the power 3 minus 2 x raised to the power 3, it's more like saying I have 1 x raised to the power 3. I'm holding 2 x raised to the power 3. Of course, I will still be holding 1 x raised to the power 3. So I can check that for x squared. I can see x squared here. I can see x squared here. I can see x squared here. So we have 3 x squared. please, you need to always exhaust all your terms here. It's very key. If you don't exhaust it, you would obviously get a wrong answer. So I can see minus x squared minus 2x squared. That will be minus 3x squared. Minus 3x squared minus 3x squared will give me my value of minus 6x squared. All right. So I can go on with the one with the power of 1. I can see 2x here. I can see minus 3x here. 2x minus 3x will give me my value of minus x. And then I'm left with just a constant term there, 3. So can you see how you make multiplication of matrix, of polynomials very, very simply and easy? You don't have to have any issue with multiplication of polynomials. All right. So this is how we solve questions on polynomials, and we can, of course, I believe we all understand all I've been saying. Probably I should give you something to do when you are all alone. Probably I give you at the end of the class. I want us to quickly delve into division of polynomials. Now, this is where I really want to explain a lot of things, because this is a place where lots of questions do come out from, and it's a very examinable aspect of polynomial, and that's why I would love you to be very sound when it comes to divisions of polynomials. So let's start from scratch and let's act like we were laymen when it comes to polynomial. Let's see how we are going to be able to bring out all the formulas that has to do with divisions of polynomials. Now, let's start with a very amateur approach. Let's act like we're just going to divide two polynomials together, and you will see how we're going to produce all the formulas associated with division of polynomials, and you understand that it's not difficult at all. I wrote a formula yesterday, and some people wanted me to explain it, and I promised I was going to explain it when we had a polynomial class. So I want to explain that formula right now. All right. So now, divisions of polynomial. How do we divide two polynomials? Now, let's assume we have two polynomials. Let's call the first polynomial polynomial 1, and let's call the other polynomial polynomial 2. Good. I want you to understand that just like, let me start from where you understand and move to polynomials from there. If I told you to divide 10 over 2, of course, you will tell me that you got an answer of 5. Now, this gave me an answer of 5, remaining 0. I'm sure everybody agrees with that. That my answer was 5, remaining 0. That means I didn't have a remainder. But if I told you to divide 10 over 3, you would say your answer was 3, remaining 1. That means 3 goes in 10 3 times, and you were left with 1. Now, you see, this particular thing we call quotient. This is it right here. This 5 is what we call, this 3 is what we call quotient. You'll be seeing me using the word quotient. This is the quotient here. That means the value you got when you made the division is your quotient. And then you'll be having what we call remainder. So whatever was, of course, left is your remainder. All right, good. Now, I want to submit to you that if you have two polynomials, the same also applies. So when I have P1 divided by P2, when I have P1 divided by P2, this will be equals to the quotient plus remainder over the divisor. Now, I'm going to use this to relate it back. This particular, I'm sure you can all relate to this. So we're going to use this to explain that. Look at what we are talking about here. Will you tell me I'm wrong if I say 10 over 3 is equals to 3 plus 1 over 3? I'm sure you won't say that, because this is all that just happened. Following this particular logic I gave here, that means when you are trying to divide a polynomial by another polynomial, the answer will be the quotient plus the remainder over whatever the divisor was. Let's try and see if what is in the right hand side is the same thing as the left hand side. That means it's 10 over 3 equals to this. Of course, you can go on by just finding the LCM of this. Find the LCM, this will give you 9 plus 1. That's 10 over 3. So you can see that this works. Let's try it for something else. Let's try another value. Let's try 21 over 2. 21 over 2. So 21 over 2, by definition of what I wrote here, should be equals to 10 as a quotient plus remaining 1 over 2. If you don't understand, I'm going to break it down. I had 21 over 2. If I decide to divide 21 divided by 2, I'm sure you know that 2 can go into 21 10 times. But it doesn't go perfectly. You are left with a remainder of 1. So I'm now deciding to express my 21 over 2 as this, based on what I wrote here. And I want to prove to you that what I wrote here is perfect. Now, once you are making a particular number divided by another number, it's going to be equals to the quotient, which was how many times it went there, plus whatever was left, the remainder, over 2. Over whatever the divisor was. So this P2 here, don't forget, it was the divisor here. So it's remainder over the divisor. So since 2 was the divisor here, that's why we have 1, which was the remainder over 2. Now, you can go on to prove this if this is going to be 21 over 2. 10 plus 1 over 2, it will be the same thing as 21 over 2. You can try that. Make the LCM. We'll be having 2. Then this will be what? 1 go here, 2 will be good. This will be 20. 20 plus 1, which is obviously 21 over 2. So you can see that this formula is accurate and perfect. So it works. So this is a formula I want you to always understand, that when you're dividing anything by anything, it's always going to be equals to the quotient. That means the answer you're going to get plus the remainder over the divisor. It will always work that way. So note this perfectly well. This is the basic on which we're going to define the next formula I'm going to be giving you. All right, I'm sure everybody could understand and relate to what I just said. So when you're making a division of anything, this will always hold. Now, let me go on now to try and use this particular formula to establish a rule under polynomial. So now that I have this, and I'm sure nobody disagrees with me, because I'm sure you all agree that it works. I've showed you at least 2 different examples with something you can relate with, and you can see that it always works. That a particular number over another number is always equals to whatever your result is, which is what we call the quotient, plus the remainder over whatever the divisor was. All right. Now that this is the case, so let's establish something very quickly. Let's take, for instance, that we just wanted to say we wanted to make this much simpler. So we had P1 over P2 is equals to Q plus R over P2. Of course, we can make this easier because we can see P2 here, we can see P2 here. So it won't be wrong if I decided to divide through by P2. Sorry, multiply through by P2. That means I'm going to multiply each of the terms with P2. Each of the terms. So I'm multiplying through by P2. just to make things much simpler. So obviously I'm going to get, of course, when you multiply this with P2, we cancel P2, you have left with P1 equals to, multiply Q with P2, will be left with Q times P2, obviously, and multiply this with P2, of course, this will cancel this, will be left with R. All right. Now, this was the formula that I wrote yesterday, and I told you that I can prove it. So, on this basis of which I established this, that when I have two polynomials being divided by each other, it's equals to the quotient plus the remainder over the divisor. I was not able to, from here, come here, which was what I wrote to you. Let me tell you exactly what I wrote. Yesterday, I wrote this. This was what I wrote. Of course, now, I'm sure you can agree that I can change P1 to a more general term because P1 here is saying a polynomial 1. I can decide to say P of X now as the polynomial. So, in this case, that means imagine I was saying it like this, that I had P of X over a divisor, which was obviously a function of X also. So imagine I did not want to use P1 and P2. I wanted to use a more general term because this is not general. This is more like you're already specifying that a polynomial 1, a polynomial 2. I could say P of X, any polynomial divided by another polynomial which we are naming D of X. D representing divisor. So this is the divisor here. Of course, I can say it equals to the quotient, which I can also signify as being having a function of X, plus, of course, I'll be having R, which in some cases, it's also a function of X, divided by, this will be the divisor also, that will be D of X. So this is me generalizing now. I'm generalizing at this point because this is specific to P1 and P2. Now I'm saying any polynomial divided by another polynomial, which we call D of X, the divisor, is equals to the quotient, whatever we're going to get, plus the remainder over the divisor. So now bringing that to this form, of course, P1 now is the P of X and our D of X is the P2. So I can write this as equals to, of course, I'll be writing my Q now in terms of X also. I'll be QX times D of X plus RX. This was what I wrote yesterday. You may decide not to put the times here so that it can align much better. So this was what I wrote yesterday for you, and I used it to solve a question, and I told you that I would explain how you actually got this formula. So the formula is quite easy. It's just on the basis of what we have here. So in order to simplify, we divided through by the divisor. We multiplied through by the divisor rather, and we're able to establish what we have here. So this is the formula that you'll be seeing being used, which I'm sure if you can go back to the lesson of yesterday, the tutorial of yesterday, you will see how this formula was used. We're able to use it to get, I believe, maybe the quotient or something. So you can always use this to, if in a case where you're giving, okay, I think what they asked us to do yesterday was that they gave us the quotient, they gave us the divisor, they gave us the remainder. In that case, you can easily form the polynomial. I believe that was the question we solved. We were told to form a polynomial, and they gave us the quotient, they gave us the divisor, they gave us the remainder. So all you needed to do there was just to fix all these things into this formula, and you will get the polynomial that was expected. All right. Now, before we go on, I want you to understand that we won't be able to complete everything on polynomial today. So we will have to pick back, I believe, tomorrow. There's still a lot to talk about. We want to talk about factor theorem. We want to talk about remainder theorem. And I would try and see how to quickly just solve one, just to give you an exposure to division of polynomials. I will solve one question, and we can pick back tomorrow by 6 again to discuss more on polynomials. We will discuss more on solving more questions and also solving, talking about the factor theorem and the remainder theorem and every other thing that we have to talk about. All right. Now, the most familiar way of solving division of polynomials is using like the tree diagram, where we make use of a particular format. But I want you to know that that's not the only way we could solve using coefficient comparison. in some cases, depending on the question we're given. So it's not every time we would have to make divisions in order to get our question solved. So let's say let's solve this question quickly. We have two polynomials and we're told to divide them. Let's see what the answer is going to be. We have this polynomial. We're asked to divide x squared plus x plus 2. We're told to divide this by x minus 1. You should never miss a question on polynomial after these classes because it's quite very simple. We are told to divide this. Okay, and let's see, how do we solve this? What's the metrics around solving division of polynomials? Very, very simple. The very first thing you have to do is to draw down your diagram. This is how you draw it. And I want you to know that for this diagram, don't always forget, whenever you have whenever you have this diagram, your divisor is what is outside, and your polynomial you're trying to divide is what is inside. Always remember that. And there's a very important rule you must never forget. When you're dealing with division of polynomials, the power of your divisor must not be greater than the polynomial. Your divisor must never have an higher power than the polynomial. So never forget that. All right. So what do we do now? We fix in, of course, our polynomial inside here. And then we'll fix in the divisor here. All right. So this is what we're going to do. You see, this very first variable, x, the very first variable of the divisor, you would use it. You'll be speaking using this to the very first here. That's the logic around this. So in this case now, I'm going to say x go in x squared. X go in x squared. That's what you're going to say. X go in x squared. Of course, if you try to solve that, you get a value of x. Now, it's best you fix this value under, not under this place, but under the second one. So we have x go in x squared, we have the value of x. All right. Now, don't forget, whatever I get on the top here is going to be your quotient. Let me write that here for you. So whatever I get on the top here will be my quotient. And after I'm done solving, I'll be getting the remainder. So this is the way the tree is plotted. You need to understand where every of the details stands. So on top of the tree is my quotient. Now, x goes in x squared, we have x. All right, that's the very first thing. You stop there. Then you make use of this x that you got. You use it to multiply all the terms of the divisor. And you write those terms under the polynomial. All right, so x times x, we have x squared. And x times minus 1, we have what? Minus x. So what do we do next? We go on to subtract. We have x minus x squared, that goes away. Then we have x minus minus x. That will give me a value of what? 2x. All right. X minus minus x will give me, because minus times minus will be x plus x. That will give me 2x. So you go on to bring down the leftover term, that was 2. So you bring that down, so you'll be having a plus 2. You bring that down. Now, you are done with the very first phase. You then go on again. Since you can see that the value here is still equal, we don't have it greater than what we have here. Imagine in a case where you had x squared here. If you had x squared here, you would not be able to say x squared goes in 2x. But since I can still see that this is still possible, then I can go on to make that happen. So x go in 2x. What do I get there? I get the value of plus 2. All right. So you write whatever answer you got on the top here. That will be plus 2. All right. And you will then use that 2, that new one. Pay attention, please. That 2 you got, you will use it to multiply each of the term. Now, you will not be using the x, you'll be using just the plus 2. So plus 2 times all the x values, all the divisor value rather, you'll be having 2 times x, that will be 2x. 2 times minus 1, that will be minus 2. All right, you do the same thing, you go on with your subtraction. When you decide to subtract this, what do you get? 2x minus 2x, of course, that goes away. That's 0, so you don't have to write that. Then 2 minus 2. What do you get here? That's 2 plus 2. That will give me a value of 4. Now, you can see that we cannot go on now to say x goes in 4 because that's not possible. So this has to be where we stop this division. Now, we can go on to now identify that, of course, my quotient, this is my quotient here. This is my remainder. And this is my, of course, this is my divisor. And this was my polynomial. So you can see how this goes. We will do more of this in the next class. This is just an introduction to this. And now let me try and now bring it in a format where, don't forget what I told you initially. I told you that P of x over D of x is equals to Q of x plus remainder over D of x. This was what I told you. So if we go on to use what we have here, you can see that x squared plus x plus 2 over x minus 1, which was the divisor, is equals to the quotient. That will be x plus 2, the quotient, that's the quotient, plus, now the remainder. What was the remainder? The remainder was 4. That will be 4 over the divisor, x minus 1. So this is perfect. This is very much perfect. And if you want to now make this, of course, much better now, you can go on to now multiply both sides by x minus 1. Like I remember I wrote a new formula where I said P of x is equals to D of x, Q of x plus R. So let's try and put it in that particular format. So we'll be having x squared plus x plus 2 equals to, now we have x minus 1, x plus 2 plus 4. That's simple, that's straightforward. You can see how this thing goes. So anyhow you leave it, this format or this format, you are still good to go. So this is essentially how you solve division of polynomials. So in our next class, we'll be solving more questions on division of polynomials. But as promised, let me give you a question on division of polynomials and multiplication of polynomials. So we start from there in our next class, which will be tomorrow. And I expect you to make a good practice of this particular question so that you get more familiar with this topic and you are able to become a pro in anything polynomials. There are several questions on this topic in your exams, several of them. And again, by 9 p.m., we'll be solving some of them. Some questions on polynomials will be coming up by 9 p.m. We have a good number of questions to solve. A whole lot of questions are available. I'm not sure we can exhaust them this night, but you will do well to attend and make sure you are prompt while attending, because we'll have to start quickly and because of the time. So let me give you this question and I expect to get this solution tomorrow. So you have to divide 4x cubed 4x cubed minus x squared plus x minus 5 okay, 4x cubed minus x squared plus x minus 5. You are supposed to divide that by another polynomial, x squared plus x minus 1. All right. So I would love you to make an attempt using exactly what I just explained for this question. And then the other question on multiplication of polynomial I promised to give you. All right. So you have, you're told that if a polynomial 1, if polynomial 1 is given as x squared, this was question number 1. So question number 2 will be if polynomial 1 is equals to x squared minus 2x plus 4, and polynomial 2 is equals to x squared plus 5, and polynomial 3 is equals to 2x minus 3. So you have to find the following. The first one you have to find P1, P2, and the second one you're supposed to find P2, P3. So this is where we're going to stop this particular class. So you are expected to solve these questions before tomorrow. By 6 p.m. we'll pick back on polynomials. We're supposed to make discussions more on divisions of polynomials. And also we're supposed to start talking about the factor theorem, the remainder theorem, and all you need to know what does this theorem state and how do you apply them in solving questions. There are so many questions around polynomials, and I want you to pay real attention. So please try and solve this question before the class tomorrow by 6 p.m. I would love to see you guys, and much more of you coming around tomorrow. All right, guys, it's been a beautiful moment. Thank you for joining. Thank you very much. By 9 p.m. we're going to be seeing again this night, 9 p.m. and lots of questions are available. So make sure you come promptly, and yeah, that'll be all for this time. Thank you very much.